welcome to this explainer. Today, we're going to tackle a really crucial topic for all you infrastructure admins out there. We are covering NCP-MCI 7.5, 14.7, heterogeneous clusters and resilience capacity. We're going to take a steady deep dive into exactly how to plan your capacity around the smallest fault domain unit. Because at the end of the day, we need to ensure that resiliency can always, without fail, be restored after a hardware crash. Okay, let's just jump right in by asking the foundational question that honestly should drive every single architectural decision you make in a Nutanix environment. Picture your own setup for a second. What exactly happens to your cluster's data if your largest, absolute most capacity-heavy node just goes dark right now? Is your data actually safe? Does the cluster have the breathing room to self-heal? Nailing the answer to this question isn't just the key to passing this specific section of the NCP-MCI 7.5 exam, though it's huge for that. It is literally the key to keeping your production workloads running when things go sideways. So to get you fully prepped for the exam, here's our roadmap for today. We'll start with the core concept of resilient capacity, then look at the application of heterogeneous node failures, followed by the application of storage-only node resiliency. After that, we'll navigate a few common exam traps and wrap it all up with the key facts you need to memorize. All right, let's kick things off with Section 1, the core concept, resilient capacity. Listen, the absolute most crucial point here is that resilient capacity is not just your total raw storage. Far from it. It's actually the usable space left over after the system explicitly reserves enough capacity to self-heal and rebuild data following a failure domain crash. In any Nutanix cluster, hardware failures are treated as an inevitability, right? They're not some rare anomaly. So when you're sizing a system, you can't just look at what your VMs are consuming today. You have to account for the spare capacity required for rebuilding operations tomorrow. Because if you don't reserve this space, a single node failure is going to leave your entire cluster permanently degraded. Let's map out how this actually works. When a host fails, say an offline controller virtual machine or CVM goes down, the hyperconverged infrastructure cluster doesn't just sit there waiting around for a technician to swap a drive. No way. It immediately relies on the remaining healthy CVNs to instantly begin rebuilding lost replicas on the surviving healthy disks. It does this to aggressively restore fault tolerance, re-replicating data across the cluster to maintain whatever replication factor you've configured. But here's the catch. The Stargate and Curator services, which handle all this, can only perform this self-healing magic if there is physical empty space available on those surviving nodes to actually receive the new replicas. Moving right along to Section 2, Application Heterogeneous Node Failures. Let's make this real. Imagine you're managing a mixed cluster, meaning the node capacities aren't identical. Let's say you've got a 5-node cluster configured for a standard 1-node or 1-disk fault tolerance, which we usually just abbreviate as 1N/1D. Now, 4 of those nodes are a bit older, bringing about 10 terabytes of capacity each. But your 5th node? It's a massive, newer node with 40 terabytes. When the system calculates your necessary failover overhead, it doesn't just casually average the storage out across the 5 nodes. It can't. The cluster must assume the absolute worst-case scenario. It has to look at the board and ask, what if that specific 40 terabyte node is the one that catches fire? And because of that logic, the system rigidly reserves a full 40 tebibytes for rebuild capacity. Resiliency planning always revolves around the single largest unit in your configured failure domain. Think about the math here. If that giant 40 tebibyte node is packed with unique data and it completely dies, all 40 tebibytes of that data must be rebuilt across the remaining 4 10 tebibyte nodes. If your cluster usage had already gobbled up the free space on the smaller nodes, the rebuild would just physically fail. There wouldn't be anywhere to put the data. In fact, the Nutanix Advanced Administration Guide is super direct about this. It states, consider the fault tolerance capacity and ensure that the usage is maintained below fault tolerance value. This quote hits the nail on the head as to why we track this so obsessively. Your system distributes data, specifically extent groups, across all nodes to optimize your read and write performance. But if your actual usage creeps up above that reserved fault tolerance value, a simultaneous failure means you literally cannot rebuild your data. You'd be operating totally without a safety net, just one random drive failure away from permanent data loss. That brings us to Section 3, Application Storage-Only Node Resiliency. Now, storage-only or SO nodes are fantastic. They let you add bulk storage capacity to a cluster without forcing you to pay for compute resources you don't actually need. They run a CVM, sure, but no local user virtual machines. However, Because these things often hold vastly more storage than your standard hyperconverged nodes, introducing them can create a massive imbalance in your fault domains. To keep your data strictly safe during a failure, Nutanix has a hard and fast architectural rule that you absolutely must memorize for the exam. It's called the replication factor +1 rule. So how does this play out? Well, if your cluster is running at replication factor 2, meaning you're keeping 2 copies of all data, you must deploy a minimum of 3 storage-only nodes. If your cluster is running replication factor 3, it demands at least 4 storage-only nodes. Why the extra node? Because if one of those massive storage-only nodes drops offline, the cluster desperately needs enough distinct surviving SO nodes to rebuild those huge extents without violating the replication factor separation rules. Never, ever deploy just 1 or 2 high-capacity storage-only nodes and trick yourself into thinking your cluster is resilient. It's an illusion. Okay, section 4, pitfalls, common exam traps. When you sit down for the certification, you have to remember this incredibly rigid compatibility rule about mixing hardware. You are totally allowed to introduce all-flash HCI nodes into an existing hybrid cluster. That is 100% supported. However, you absolutely cannot add older hybrid nodes, meaning nodes with traditional spinning hard drives, into a pristine existing all-flash cluster. Why? Because the performance disparity would instantly drag down the entire storage pool, completely wrecking the high-speed, predictable latency that an all-flash cluster is specifically designed to guarantee. The exam is absolutely going to try to trick you by reversing these 2 scenarios, so lock this rule in your brain right now. Also, if you have the reserve rebuild capacity feature toggled on in Prism Element, which is a great feature that protects your cluster by hiding the rebuild space from the available storage pool, there are 3 major edge cases you need to be aware of. First, the oplog, which is your persistent write buffer handling random bursts, is strictly counted against your total usage. Second, when a node fails, the data consumption of that specific failed node is immediately excluded from the total usage, which gives the cluster accurate metrics during the rebuild phase. And third, actually, this is the most critical one for an admin. If your total capacity usage hits 95% of your resilient limit, the cluster will literally stop accepting write requests. It does this to protect itself from a catastrophic full disk scenario that could corrupt the file system, but from your perspective, it means your VMs are essentially paused. You never ever want to hit that 95% threshold. All right, let's bring it all home. Section 5, Summary, Key Facts to Memorize. For the NCP-MCI 7.5 exam, I want you to memorize these 4 absolute facts. Number 1, always size your rebuild capacity around the single largest node or unit in your failure domain. Number 2, when adding storage-only nodes to heterogeneous clusters, you must strictly follow the replication factor +1 deployment rule. Number 3, you can add flash to a hybrid cluster, but you can never put hybrid hardware into an all-flash cluster. And number 4, respect that resilient capacity limit, because the second you hit 95% usage, write requests are suspended and your applications are going down. As you head back to your own data center designs and prep for this exam, I want to leave you with this final thought. Look at your mixed clusters today and ask yourself honestly, is your cluster truly resilient with properly calculated reserved capacity? Or is it just one large node failure away from an irreversible outage? Understanding the difference between those 2 realities isn't just about passing the NCP-MCI 7.5. It's about being a truly exceptional infrastructure administrator. Thanks for joining me on this explainer, and best of luck on your certification.